Good morning to everyone. Today's topic is differential calculus and the subtopic is Taylor's theorem of a function of two variables. Example 2. Expand e power x into cos y in a Taylor series about the point 1, pi by 4 up to second degree terms. Here f of x comma y is equal to e power x into cos y, and also given the point is 1 pi by 4. From this a is 1, b is pi by 4. Here you can observe they mention up to second degree terms. Whenever they mention like this, then we are going to get a Taylor's polynomial. So we can start solving the question. Solution: a comma b equal to 1 pi by 4. So a is 1, b is pi by 4. Given function is f of x comma y equal to e power x into cos y. Now I am going to evaluate the value of the function at 1 pi by 4. That is f of 1 pi by 4 equal to e power 1 into cos pi by 4. But e power 1 is e only. We know the value of cos pi by 4, that is 1 by root 2. Multiply these two terms, then we are going to get e by root 2. That is the value of f at 1 pi by 4 is e by root 2. Now we are going to find out first order partial derivatives. Those are fx and fy. Fx of x comma y is equal to, how to calculate this one means, given that f of x comma y is e power x into cos y. Now we are doing partial differentiation with respect to x. So y is constant. Whenever y is constant, cos y is also constant. So put cos y as a constant. E power x differentiation is e power x. So the value of fx is e power x into cos y. Now we calculate the value of fx at 1 pi by 4. That is cos pi by 4, y value is pi by 4. E power x, x is 1, that's why e power 1 is e. Already we know cos pi by 4 is 1 by root 2. 1 by root 2 into e is e by root 2. Next, partial differentiation of f with respect to y. Whenever we are going to do partial differentiation with respect to y, x is constant. X is constant. So e power x is also constant. Into cos y differentiation is minus sin y. Now we calculate the value of fy at 1 pi by 4. Put x equal to 1, y equal to pi by 4. So e power 1, that is e only, minus sin pi by 4. We know the value of sin pi by 4, that is 1 by root 2. E into minus 1 by root 2 is minus e by root 2. Next we are going to find second order partial derivatives. Second order partial derivatives are 3, that is fxx. Next one is fxy. Next one is fyy. First of all, we are going to find out fxx. How we are going to find fxx means differentiate fx with respect to x. So here we are doing partial differentiation with respect to x. That's why cos y is constant. E power x differentiation is e power x only. Now we are going to find out the value of fxx at 1 pi by 4. Substitute y equal to pi by 4, x equal to 1. So cos pi by 4 into e. We know the value of cos pi by 4, that is 1 by root 2. 1 by root 2 into e is e by root 2. Next partial derivative is fxy. This one we can calculate by using fx only. Now I am going to do partial differentiation of fx with respect to y. Then we will get fxy. So we are doing partial differentiation with respect to y means x is constant. So e power x is constant. Cos y differentiation is minus sin y. Now find out the value of fxy at 1 comma pi by 4. That is when replace x with 1, y with pi by 4. So e power 1 is e only minus sin pi by 4. We know the value of sin pi by 4, that is 1 by root 2. So e into minus 1 by root 2 is minus e by root 2. Next we are going to find out fyy. How to calculate fyy means differentiate fy with respect to y. Here observe, we have fy value as minus e power x into sin y. We are doing partial differentiation with respect to y, that's why e power x is constant. Here y minus is also there, that's why I am putting minus e power x aside. Now I am going to do partial differentiation of sin y, that is cos y. Find out the value of fyy at 1 comma pi by 4 minus e power 1 e cos pi by 4. This is 1 by root 2. That's why the simplification is minus e by root 2. Now I have all values, that means fx, fy, fxx, fxy, fyy at 1 comma pi by 4. Now I am going to substitute these values in Taylor's series. Taylor's series of f of x comma y is f of x comma y equal to f of a comma b plus 1 by 1 factorial x minus a fx plus y minus b fy plus 1 by 2 factorial x minus a whole square fxx plus 2 into x minus a y minus b fxy plus y minus b whole square into fyy. Here I am not writing plus dotted lines because in the question they asked obtain Taylor series for the function up to second degree. That's why I am going to stop here. That's why I am not writing no dotted lines. Okay. F of x comma y is equal to the value of f of a comma b is e by root 2. I am going to substitute that value plus 1 by 1 factorial as it is. We already know the value of a, that is 1. That's why x minus 1. Fx value is e by root 2 plus we know the b value also, that is substitute. Then we are going to get y minus pi by 4. The value of fy is minus e by root 2. So second term of the Taylor series is completed. Now we move to write the third term of the Taylor's series plus 1 by 2 factorial x minus 1 whole square. The value of fxx is e by root 2 plus 2 into x minus 1 y minus pi by 4. Fxy value is minus e by root 2 plus y minus pi by 4 whole square. Fyy value is minus e by root 2. So now I am getting the final answer, that is the Taylor series of given function up to second degree terms. Next is simplification of this RHS. Observe, every term contains e by root 2. So, take e by root 2 common. After taking e by root 2, here we are going to get 1 plus 1 by 1 factorial is 1 only. E by root 2 is outside. So, x minus 1 plus into minus is minus y minus pi by 4. This term is outside. Plus 1 by 2 factorial is there. That means 1 by 2 only. Here also e minus e by root 2, e by root 2, e by root 2. I am taking these terms out as a common. The remaining terms are x minus 1 whole square plus y here minus means minus into plus is minus 2 into x minus 1 y minus pi by 4. Here also we are going to get minus only because plus into minus is minus y minus pi by 4 whole square. After simplification, this is the final Taylor series of given function. Next example 3. Expand xy square plus cos of xy about 1 comma pi by 4 up to terms of second order derivatives. Here also it is enough to find the partial derivatives fx, fy, fxx, fxy, fyy. The given function is f of x comma y equal to xy square plus cos of xy. About the point, this is the given point. We want to find out Taylor series of this function about this point. So, compare this point with a comma b. Then we know the values of a and b. A equal to 1, b equal to pi by 2. First of all, we are going to find out the value of f at 1 comma pi by 2. So, replace x with 1, y with pi by 2. 1 into pi by 2 whole square plus cos of 1 into pi by 2. So, pi by 2 whole square value is pi square by 4 plus here we have cos of 1 into pi by 2, that is cos pi by 2 only. Cos pi by 2 value we know that is 0. So, pi square by 4 plus 0 is pi square by 4. So, the value of f at 1 comma pi by 2 is pi square by 4. Next we are going to find out the partial derivative of f with respect to x. So, same with respect to x means we are treating y as constant. Whenever y is constant, y square is also constant. Therefore, I am writing y square here. For x, the differentiation is 1 minus y minus means observe once f of x comma y is xy square plus cos of xy. This is totally angle xy is. So, partial differentiation with respect to x means y constant. So, y square constant. For x1, I am putting plus as is. We know the differentiation of cos is minus sine of xy. So, by using chain rule, cos differentiation is completed. Next, we are moved to differentiation of xy. In this xy, y is constant because we are doing partial differentiation with respect to x. For x 1. So the simplification is y square plus into minus is minus y sine of xy. This is the value of partial differentiation of f with respect to x. Observe here the same thing I have written. Now find out the value of fx at 1 comma pi by 2. Substitute x equal to 1, y equal to pi by 2 in this expression. So y square means pi by 2 whole square, that is pi square by 4, minus y is pi by 2, sine of x is 1, y is pi by 2. So pi square by 4 as it is, minus pi by 2 also as it is. Sine of 1 into pi by 2 is sine pi by 2. We know the value of sine pi by 2, that is 1. 1 into anything is anything. That's why we are getting pi by 2 here. So the value of fx at 1 comma pi by 2 is pi square by 4 minus pi by 2. Now we find partial differentiation of f with respect to y. With respect to y means x is constant. For y square, differentiation is 2y. Again, I am putting plus sign. Cos differentiation is minus sign. xy I am writing as it is. By using chain rule, cos, after completion of differentiation of cos, we move to differentiation of angle. Here, with respect to y means x constant, for y 1. So the simplification of this term is 2 into xy minus x into sine of xy. Now find out the value of fy at 1 comma pi by 4. So 2 into 1 into pi by 2 minus 1 into sine of 1 into pi by 2. Simplify this term. Observe 2 get cancelled. Then we are going to get pi. Sine pi by 2 is 1. 1 into 1 is 1. So the value of fy at 1 comma pi by 2 is pi minus 1. Now we are going to find out second order partial derivatives. First one is fxx. How we are going to get fxx means partial differentiation of fx with respect to x again. So with respect to x means y is constant. So y square is also constant. Constant differentiation is 0. Minus y is constant. That's why I am not doing any differentiation for y. I am keeping y as it is. Sine differentiation is cos of xy. Again, by using chain rule, I want to do partial differentiation of angle. So here also y is constant, for x is 1. Finally, the partial differentiation of fx with respect to x, that is fxx is minus y square cos of xy. Now I am going to find out the value of fxx at 1 comma pi by 2 minus y square. Pi by 2 whole square is pi square by 4. Cos of 1 into pi by 2 is cos pi by 2. We know the value of cos pi by 2, that is 0. 0 into anything is 0. So fxx value is 0. Now I am going to find out fyy. Fyy means partial differentiation of fy with respect to y. While doing partial differentiation with respect to y, we are treating x as constant. That's why 2 is constant, x is already constant. For 1 y, the differentiation is 1 minus x is constant. Sign differentiation is cos of xy. By using chain rule, angle differentiation is x constant, for y 1. So the simplification of this one is 2x minus x square cos of xy. Now we find out the value of fyy at 1 comma pi by 2. So 2 into 1 minus 1 square cos of 1 into pi by 2. So 2 into 1 is 2 minus cos of pi by 2. We know the value of cos pi by 2, that is 0. So 2 minus 0 is 2 only. So the value of fyy at 1 comma pi by 2 is 2. Now I am going to find out fxy, that is partial differentiation of fx with respect to y. Whenever we are going to do partial differentiation with respect to y, treat x as constant. So y square differentiation is 2y. Here you can observe, here we have y, here also we have y. That's why we are going to use product rule. First function into, that is y into differentiation of second one, sign differentiation is cos xy, angle differentiation is x constant for y 1, plus second function, that is sin of xy into y differentiation is 1. Once again, first I am treating this as first function, this as second function. First function into differentiation of second one, sin of xy differentiation is cos of xy into x into 1, plus second function into differentiation of first function, that is y differentiation is 1. So the simplification of this one is 2y minus x into y cos of xy. Here you can observe minus is belongs to this term also. So minus into plus is minus sin of xy. So this is the value of f of xy. Now we are going to calculate the value of fxy at 1 comma pi by 2. So 2 into pi by 2 minus 1 into pi by 2 cos of 1 into pi by 2 minus sin of 1 into pi by 2. Then we are going to get this step. 2 to get cancelled. So pi minus 1 only. Why minus 1 only mean? Because cos pi by 2 is 0. So this term vanishes. Minus sin pi by 2. The value of sin pi by 2 is 1. That's why we are going to get minus 1 here. So the value of fxy at 1 comma pi by 2 is pi minus 1. Now I have all values, that means all partial derivatives, first fx, fy, fxx, fxy, fyy at 1 comma pi by 2. Now I am going to substitute all these values in Taylor series. The Taylor series is of the form f of x comma y equal to f of a comma b plus 1 by 1 factorial x minus a into fx plus y minus b into fy plus 1 by 2 factorial into x minus a whole square fxx plus 2 into x minus a into y minus b fxy plus y minus b whole square into fyy. So this is the Taylor's series. Now I am going to substitute all known values. We know the value of f of a comma b, that is pi square by 4 1 by 1 factorial x minus 1, fx value is this one, plus y minus pi by 2, fy value is this one, 1 by 2 factorial x minus 1 whole square, fx's value is 0, plus 2 into x minus 1, y minus pi by 2. fxy value is pi minus 1 plus y minus pi by 2 whole square, fyy value is 2. Now the substitution of all quantities completed. Now I am going to do simplification. Pi square by 4 plus 1 by 1 factorial is 1 only. X minus 1 as it is. This one also as it is. This second term is not changing. I am going to write as it is. Plus 1 by 2 factorial. If you want you can write 1 by 2. 0 into anything 0. So first term vanishes. Second term is as it is. Third term also as it is. So this is the required Taylor series of given function about the point 1 comma pi by 2.